In recent years, astronomical discoveries have begun to challenge long-established ideas about the universe's age and the fundamental processes that have shaped it. For much of the last century, the prevailing understanding of the universe was that it began roughly 13.8 billion years ago, in an event known as the Big Bang. This theory has been supported by a variety of observations, including the cosmic microwave background radiation, CMB, and the Hubble constant, which measures the rate of expansion of the universe. However, a series of groundbreaking findings, especially those made by the James Webb Space Telescope, JWST, has caused some scientists to reconsider the true age of the universe. These discoveries have led some researchers to propose a recalculation, suggesting that the universe may be much older than previously thought, possibly as old as 26.7 billion years, or even older. The James Webb Space Telescope, launched in December 2021, has proven to be one of the most powerful instruments ever created to observe the farthest reaches of space. With its infrared capabilities, JWST can peer deeper into space, and thus farther back in time than ever before. One of its key missions has been to study the early universe, searching for clues about the formation of galaxies, stars, and other cosmic structures. What the telescope has found so far has been nothing short of revolutionary. Among the most surprising discoveries made by JWST is the detection of highly evolved galaxies that appear to have formed much earlier than expected. These galaxies, many of which bear a striking resemblance to our own Milky Way, were discovered at a time when the universe was thought to be in its infancy, just a few 100 million years after the Big Bang. In the past, it was believed that galaxies took billions of years to develop the well-defined, spiral shapes we see in more mature galaxies like the Milky Way. However, these new findings challenge that assumption. The concept that the early universe was chaotic and disorganized is a fundamental part of our current understanding of cosmic history. According to traditional models of galaxy formation, the first galaxies were small and irregularly shaped, often merging and interacting with other galaxies in violent collisions. These collisions were believed to be the key driver of galaxy evolution, as smaller galaxies combined to form larger, more structured ones. However, JWST has found that many of the galaxies it has observed, even in the early universe, show remarkable levels of organization and complexity. Some of these galaxies appear to have formed spiral arms, a feature that was once thought to develop only after billions of years of galactic evolution. This has led some researchers to propose that the early universe may have been more conducive to galaxy formation than previously thought, and that galaxies may have evolved much faster than traditional models suggest. One of the most intriguing galaxies discovered by JWST is known as CIRS 2112. This galaxy was found when the universe was only 1.5 billion years old, a time when most galaxies were still in their formative stages. What makes CIRS 2112 so remarkable is that it bears a striking resemblance to the Milky Way, even at this early stage of the universe. The Milky Way, as we know it today, took billions of years to develop its distinctive spiral arms and disc-like structure. The fact that CIRS 2112 has such a well-defined shape at such an early stage in the universe's history has led scientists to question whether the conventional model of galaxy formation is accurate. For many years, it was thought that galaxies like the Milky Way could only form much later in cosmic history, after numerous galactic mergers and star formation events had occurred over billions of years. However, CIRS 2112 challenges this idea, suggesting that large, structured galaxies may have been able to form much earlier than we previously thought. In fact, some scientists are now considering the possibility that the process of galaxy formation could have been much faster than previously believed, and that the early universe may have had conditions that allowed galaxies to evolve more rapidly than our current models suggest. The discovery of galaxies like CIRS 2112 raises profound questions about the nature of the universe itself. If galaxies like this could form so quickly after the Big Bang, it suggests that the universe may be much older than the traditional model indicates. This has led some researchers, like Ranadra Gupta, a scientist at the University of Ottawa, to propose that the universe could be as old as 26.7 billion years, or even older. Gupta's hypothesis is based on an alternative model of cosmic expansion that challenges some of the key assumptions of the Big Bang theory. Gupta's theory relies on a new understanding of dark energy and dark matter, two mysterious substances that are thought to make up most of the universe's mass and energy. Dark matter, which is invisible and detectable only through its gravitational effects, has long been a source of intrigue for astrophysicists. Dark energy, on the other hand, is thought to be responsible for the accelerated expansion of the universe. Both of these phenomena remain poorly understood, and their true nature has never been directly observed. Gupta argues that the traditional models of cosmic expansion and the role of dark matter and dark energy may be flawed, and that a new approach is needed to better explain the observed data. One of the key issues with the current understanding of the universe's age is the so-called Hubble tension. The Hubble constant, which measures the rate of expansion of the universe, has been difficult to pin down with precision. Different methods of measuring the Hubble constant have yielded different values, leading to a discrepancy in our understanding of how quickly the universe is expanding. This tension has raised doubts about the accuracy of the Big Bang model, as it suggests that the expansion of the universe may not be uniform, as traditional models predict. Gupta's theory attempts to resolve this tension by introducing alternative cosmological parameters that account for variations in the expansion rate. According to Gupta's model, the universe may be expanding much more slowly than previously thought. This slower expansion could suggest that the universe is much older than the standard model of cosmology predicts. Alternatively, Gupta proposes that the expansion of the universe may be nonlinear, with certain regions of space expanding at different rates. This could indicate that there are unknown structures or forces at work in the universe, or that the universe had multiple starting points, rather than a single Big Bang event. Gupta's approach also includes modifications to Einstein's theory of general relativity, proposing that the behavior of dark energy has changed over time. If true, this could explain the observed acceleration in the universe's expansion. While Gupta's recalculation of the universe's age is radical, it is not without precedent. Other researchers have also proposed alternative models of cosmic expansion, though they have not gained widespread acceptance within the scientific community. Gupta's model, which suggests that the universe could be as old as 26.7 billion years, or even 42 billion years, has the potential to resolve some of the long-standing discrepancies in our understanding of the cosmos. If his theory is correct, it could explain the existence of highly evolved galaxies like Sirius 2112, as well as other phenomena that are difficult to reconcile with the traditional Big Bang model. One of the most fascinating aspects of Gupta's theory is its ability to explain some of the most puzzling observations in cosmology. For example, some distant galaxies and quasars appear to be far older and more developed than they should be, given the current understanding of cosmic history. These objects are often described as anomalies, as they seem to contradict the predictions of the Big Bang theory. Gupta's model, however, could provide a framework for understanding these anomalies. If the universe is much older than we currently think, then it would make sense that these galaxies and quasars could have had more time to evolve and develop the complex structures we observe today. In addition to the discovery of highly evolved galaxies like Sirius 2112, the JWST has also provided new insights into the early stages of galaxy formation. The telescope's observations have revealed that galaxies in the early universe were not as chaotic and disorganized as previously thought. Instead, many of these galaxies show signs of early galactic mergers and interactions, which are believed to have played a key role in shaping the structure of the universe. These findings suggest that the process of galaxy formation may have been more efficient and rapid than previously believed. The discovery of such well-formed galaxies in the early universe has raised serious questions about the accuracy of our current models of cosmic evolution. For decades, scientists have assumed that galaxies took billions of years to develop their present-day structures. However, the JWST's observations suggest that galaxies may have formed more quickly and more efficiently than traditional models would predict. This has led to a growing sense of uncertainty among astrophysicists, who are now grappling with the possibility that the universe is much older than we have been led to believe. While some researchers are embracing the idea that the universe could be as old as 26.7 billion years, others remain skeptical. The scientific community is notoriously conservative, and new ideas, especially those that challenge long-established theories, are often met with resistance. However, as more and more data comes in from the JWST and other observatories, it is becoming increasingly clear that the traditional Big Bang model may not be the complete story. Whether or not Gupta's recalculation of the universe's age is ultimately accepted, it is clear that the discoveries made by the James Webb Space Telescope are forcing scientists to rethink everything they thought they knew about the universe's origins and evolution. These findings are more than just a challenge to our understanding of cosmic history, they are a reminder that science is a constantly evolving field, and that our understanding of the universe is far from complete. As new discoveries are made, old theories are tested and refined, and our understanding of the cosmos continues to evolve. The James Webb Space Telescope has opened a new chapter in the history of astronomy, one that promises to shed light on the most profound questions of our existence. Whether or not we ultimately revise the age of the universe, one thing is certain: we are on the verge of a new era of discovery, one that may rewrite the very story of our universe.